Good afternoon. The next topic that we are going to take is limits and derivatives. Okay. In the next two class, we will be discussing only about limits. Derivatives will come after this. It is based on limits only. That is well. So to start the chapter, okay, we will take an example first. Okay.
Sir.
Yes.
So are you starting a new chapter today?
Yeah. So we consider here a function fx x square minus 4 upon x minus 2. Okay. Try to understand the concept of limit here with the help of this example. Okay. As you can see, this numerator can be factorized like x minus 2 into x plus 2, right, using a square minus b square. Okay, and this can be written as x plus 2. This can be written as x plus 2 if we cancel this numerator and denominator. And when we can cancel numerator and denominator, this point is important. When we can cancel them, when they are non-zero, or we have to make sure that these values are non-zero. Which values? The factors which are there in numerator and denominator, that is x minus 2. See, if like you have something like this 0 by 0, you cannot cancel it. No, you cannot write it as 1, right? This is wrong. So if you are writing that fx is x plus 2, then there should be one thing. And we have studied functions also. At that time we discussed something called domain, remember? So if we talk about domain also, then the denominator should not be 0. So this can be understood from the first step also, that x cannot be 2. Okay. So now we have this same function fx as x plus 2 if x is not equal to 2. Try to understand what is the meaning of limit. Okay, and how we develop this idea. I am going to put some certain values of x. Okay, suppose I put 2 point, suppose here I put 1.99. Okay, where I am putting this value in place of x, put it here. So what you will get from fx, you will get 3.99. Then let's say you put 1.3 times 9. So the value of fx will be 3.3 times 9. Okay. Then let us say you put 1.4 times 9. What will be fx? 3.4 times of 9. Where you are putting this? Here. Okay, in place of x. Now suppose we put 2.01. Okay, we are giving values of x and finding values of fx, so this will be 4.01. If we put 2.001, we get 4.001. Now similarly, if we put 2 point, suppose 4 times 0 and 1, then you will get 4.4 times 0 and 1. From where? This expression. Now the question is, what if I put 2? Okay, what if I put 2? If you say that your answer will be 4, it is wrong. Why? Because you cannot put 2 here. When you got this function fx as x plus 2, when x is not equal to 2. And if you actually want to put 2, then do it here. Put it here. What you will get when you will put 2 here in numerator and denominator? You will get 0 by 0. you will get 0 by 0. Okay, now in mathematics there are some indeterminate forms. We are not going to discuss all, okay, because this chapter will come in 12th class again, but the important ones like these three we'll learn here. Okay, these are called indeterminate forms. Indeterminate form means which cannot be determined. If you think 0 by 0 is 1, that is wrong. If you think 0 by 0 is infinity, that is also wrong. Okay, it is neither 0 nor infinity nor anything, nor 0. Okay, it is simply indeterminate. Because see, we can think about this answer in three different ways. One way can be that numerator and denominator are same, so answer should be 1. Then some other person can say that it is 0 in the numerator, so value should be 0. 0 divided by any number is 0. And someone can say that since 0 is in the denominator, therefore answer will be infinity. Okay, so there is no particular fixed answer. We keep such forms in indeterminate forms. Okay, we are going to study three forms here: 0 by 0, infinity by infinity, and infinity minus infinity. Like infinity by infinity, someone will say it's the same type of term, so 1. Other can say it is infinity in the denominator, so 0. And some can say it is infinity because there is infinity in the numerator. Again, no particular or fixed answer. Same is with infinity minus infinity. Infinity minus infinity is not necessarily 0. It can be any value. Why? Because see, I'm going to tell you something important. Listen carefully. Two infinities can be different also. Two infinities can be different. Now from where this term is coming, two infinities, we have only studied infinity, right? For this you can take example of natural numbers and whole numbers. If someone asks how many whole numbers are there, you will say infinity. Infinite whole numbers are there. How many natural numbers are there? Infinite. But have you ever realized that natural numbers are more than whole numbers are more than natural numbers? Why? Because you include 0 as well. So though both have infinite numbers, but actually whole number has more numbers because of that 0 thing. It is very easy to understand. So you never know from where this infinity is coming. So you cannot say that it is always 0. It can be anything. Overall, these are the three indeterminate forms which you may encounter in your maths problems. Like here, once again, when we are taking this function and when we are trying to put x equals to, okay, when we are trying to put x equals to, we are getting 0 by 0, which is an indeterminate form, right? Though you can put some other number also like 2.1, 1.9, etc., then you will be getting some number. So either you can explain it on the basis of domain, okay, that x is not equal to 2, or you can say that when we put x equal to 2, we are getting an indeterminate form. Now let us come back to this table. See what is happening. When you put 2, you are getting 0 by 0 indeterminate form. But when you are trying to put values of x which are closer to 2, see these values as well as these values on the left of 2. Okay, see this 2.4 times 0, 1, 2.2 times 0, 1, 2.01. These values will be towards the right of x equals to, we are talking about number line. And this 1.99, 1.999, these numbers will be towards the left of x equals to on the real number line. Can anyone tell me? Listen to my question first. What I am going to do, what I am trying to explain with the help of this table. In the above table, we see that when x approaches, listen and try to understand this term, approaches 2 from left side or right side. When x approaches 2 from left side or right side, then value of fx, what is the left side? If the number is to the left of 2, it is from the left side. If number is to the right of 2, it is from the right side. What I am doing in this table, I am trying to get as much as close to 2 from left and right. See 1.99, then still closer 1.999, then still closer 1.4 times 9, and it can go on. Similarly towards the right, as much as close as you can, 2.01, 2.001, 2.4 times 01, and so on. Okay. So when x approaches 2 from left side or right side, then value of fx approaches. Can anyone tell me, just by looking at this table, okay, and observing the values of fx, can anyone tell me what is that value of fx towards which its value is approaching?
4.
Very
2.
good. 4 is the answer. Do not say 0 by 0. I am saying observe the values of fx. So when you put 1.99, you are getting 3.99. When you are putting 1.3 times 9, you are getting 3.999. Okay. So it seemed like that we are moving towards 4, right? Then from the right side also. Right side, we are getting 4.01, 4.001, 4.4 times 01. And it seems like that we are almost on 4. But that is not happening, right? So this thing, okay, this whole thing, whatever is written here, okay, this whole thing, whatever is written here, this is the concept of limit. How we write this much information in mathematical terms. For limit, we use this symbol lim. Okay, we take the first three alphabets, try to understand this notation. Then below this we write x. Then this thing, this arrow is shown to represent this term approaches. And what number x is approaching? 2. Then in front of this we write the function, and then we write equal to, and then we write the value. We write it once again, limit x tends to 2. What is function here? Function is this. What is the limit of the function? 4. Now you know what is this? What is this in this circle? How to read it? I'm repeating. When x approaches 2, the function is approaching 4, one way. Second, when x is approaching 2, the limit of the function is 4. See, what is the limit? Limit means it is not the value of the function. It is the value of limit of the function. And what is limit? Approaching, trying to approach something. Okay, that is called limit. So if I write like this, when x tends to 2, then x square minus 4 upon x minus 2 is equal to 4. This is absolutely wrong. Okay, the value of the function is not 4. You can see the table. The value is approaching 4. So that is why to represent that symbol or that thing, we use this term called limit. Okay. Now this is little bit lengthy method. Every time the function will be there, they'll be giving some x and we will go on
So could
putting
you
these.
please repeat again, sir? So why x square minus 4 upon x minus 2 would not be 4? So is it because we did not take the limit?
Yeah, obviously. Value of limit is 4, value of the function is not 4. You can see from the table. Nowhere you will be getting 4. You will be getting a value close to 4. That is why to show that thing we use this symbol called limit. Okay.
Yes, sir.
Now, but what we see that this table thing is very difficult. Okay, every time there will be some function, you will be putting some values, then it will become very complicated every time we make this table. So to find the limit, now we are going to study the definition of limit, by the help of which you will be able to solve the questions. Definition of limit. So limit of fx, this is function, okay, is said to exist at x tends to a if left hand limit equals right hand limit equals finite quantity, and this finite quantity is the value of limit. This finite quantity is value of limit. How to write left hand limit? See, left hand limit means that that x is approaching from left side, that thing only. How we write this thing mathematically? We write it like this. What is this a minus? See, you might have noticed that on the number line, suppose 2 is here, then all the numbers which are to the left of 2 will be less than 2. Okay, and all the numbers which are to the right of 2 will be greater than 2. So this a minus and a plus is showing that in the first thing a is to the left of a, and a plus means that number is to the right of a. Again, value of limit. Now, last thing. See, the last two things will be clear from examples also. We put h tending to 0. In place of x, we will writing a minus h. These two terms will be clear in questions also. H tending to 0. F of a plus h equals finite quantity. Every time I am writing the finite quantity, whatever finite quantity will come, that will be the value of limit. And in the question, they ask you value of limit only. Or they will say evaluate the limit. Now, what is this thing? Let us take an example. This will help us understand everything. Suppose the question is this. Evaluate limit x tends to 2. Same question which we solved using table. Now we will solve it mathematically. This is the question. So what we are going to do, we are going to use this mathematical definition. Okay, just try to understand what is the meaning of these two lines. I will first find LHL. LHL means that I am trying to find the limiting value of this function or the approaching value of the function when x is approaching 2 from the left side. Okay. After this, one more thing I forgot to write, where h is very small positive quantity. Now from here to here, pay attention, from here to here, this, how to write? You observe that they have written h tending to 0, and in the function, okay, in place of x, they are using a minus h. What is a in this question? A is 2. See this, compare it. A is 2. So that means when you come from here to here, you are basically replacing x by a minus h. Okay. So that means in the whole function, you have to replace x by 2 minus h. You replace x by 2 minus h like this. This is the meaning. And then you solve this limit. So why 2 minus h is towards left of 2? How will ensure that 2 minus h towards left of 2? For that you should understand that in the whole chapter, this h is going to be a very small positive quantity. Okay. Now 4 plus h square minus 4h minus 4, and it is minus h here. This comes out to be, this gets cancelled. This is h square minus 4h upon minus h. Take h common. It is h minus 4 upon minus h. Think and tell me, any one of you, can we cancel h by h or not? Can we cancel h from numerator and denominator?
So no.
Why?
So h is very small, meaning it's almost tending to be 0.
Almost tending to 0 does not mean that it is 0. See, when this is the situation, when we have this situation, answer will be indeterminate, right? You cannot write 1 or any other number. But suppose if I say this 0 point, as many zeros as you want, and then same situation is here, what will you say? Is it indeterminate? No, answer will be 1. Got it? Now the same situation is here in this question. H upon H. Now H is tending to 0. It is tending to 0, fine, but it is not 0, no? That means we can cancel this. Now what is left? Minus can be adjusted in the numerator, so it will be 4 minus H. Now you try to understand that its answer will be 4. Why? Because when H is tending to 0, it is some very small positive number. So because of that, this 4 minus H will be slightly less than 4. It is that kind of situation, 3.999 like that. Okay, that is why I've used this term limit. Okay, that is why I've used this term limit, and that is why the answer is 4. Okay, when H is tending
So
to
how
0,
did
it
you
is
get?
what
So how
happened?
did you get 4 minus h? How did you get 4 minus h?
You are not cancelling H by H.
Ah, okay.
Then minus will be adjusted in the numerator, no?
Okay, sir.
Minus was also there in the denominator, right? So now what I am saying, when H is tending to 0, okay, H is tending to 0, but we know that it is a very small positive quantity. What it can be? 0.000, like so on, 1. So what will be the answer of this 4 minus this? It will be 3.999, etc. So that is why the value is not 4. That is why I'm using the symbol limit. Limit is 4. Okay, it is the same thing. It is the same thing that I explained with the help of table. You know what is happening here? We are doing this part actually. We are doing this part. X is going towards 2 from left side. Function is going towards 4 from left side. Why? Because the value of function is coming close to 4. That is the thing. So this is by table and that is mathematically. Now again, it is not over, because we cannot say or jump to the conclusion that the limit is 4. We need to find the other limit also. Other limit means RHL. Now we find RHL. RHL means limit x tends to 2 plus. This is x square. Again, write down the function. Okay. This is, now see, again you come here. From here to here, what do you observe? We write x tends to a plus. What we write in the next step? We write h tending to 0. Okay. And what we do in the function, what type of changes? We replace x by a plus h. In the previous part, we were replacing x by a minus h. Now a plus h. What is a? A is 2. 2 plus h. Okay. We solve this. So this is 4 plus h square plus 4h minus 4 upon h. Okay. This gets cancelled. Just like the previous part, you will take h common and you will cancel it. Now h plus 4 will remain, or 4 plus h, whatever you say, it is one and the same thing. And now you can say that the answer is 4, the answer of the limit. Why? Because see, when h will be tending to 0, it will be 4 plus very small number, very small, as small as you can think. So the value will be 4.0000 and so on to like somewhere 1. That is why we say that the limit is 4, because when you are going towards 2 from the right hand side, you are trying to put value of x as close as possible to 2. You are getting the value of the function as close as 4. Now what do you observe? What is the last thing? LHL is equal to RHL is equal to 4. And this is the definition. What is the definition? See, limit of fx is said to exist at x equal to a if left hand limit equals right hand limit is equal to finite quantity. So that's it. Now you can write once again if you want that limit x tends to 2, x square minus 4 upon x minus 2 is equal to 4. Why? Because from both sides it is coming same, and also it is a finite value, that is why. So this will be the answer. So now in the questions, you will be required to use this LHL RHL thing. Okay. not that tabular form. Okay, that was for the understanding. So suppose if I give you this question, limit x tends to 1, and here this is greatest integer of x. Okay, this denotes greatest integer because I have taught you greatest integer, right? Then can anyone tell me what will be your answer for the limit greatest integer function?
So is it 1?
1. What you have calculated, right hand limit or left hand limit or both?
So both.
Obviously both. So how come you are getting
So no, it's not 1.
1? See, if we find left hand limit,
So
that
0 and 1.
0 and 1, no, so limit will not exist. Now you are correct, because see, if we write like this, wait a minute, limit x tends to 1 minus, we write this greatest integer, then limit h tending to 0, in place of x you will write a minus h, right? 1 minus h. Now try to understand. Here you are going to write the value now, and why it is 0? Because what I told you about this h thing, that it is a very small positive number. So if even if it is a very small positive number, you are subtracting it from 1. So 1 minus h will be something like 0.999 like that. Okay. If you remember the greatest integer, what I told you, answer will be integer nearest but smaller. So 0.999 and so on. The nearest integers are 0 and 1. But smaller is required, so that is why value will be 0. Okay. Then regarding RHL, x tends to 1 plus. X tends to 1 plus. You write h tending to 0, and now in place of x you put 1 plus h. Now what will be the situation? This number inside this box, which is greatest integer, is slightly greater than 1. It is 1.00 like that. Okay. That means it is greater than 1 and less than 2. So greatest integer will be 1. Right? You observe that LHL is not equal to RHL. LHL is not equal to RHL. Okay. So in such situation, what is the answer? Answer is limit x tends to 1, greatest integer x does not exist. This will be the answer, because in the definition itself I told you a limit of fx is said to exist like this when LHL is equal to RHL is equal to finite quantity. Here both of them are unequal, that is why we will say that limit does not exist. Okay. Try this third question now. Limit x tends to 0, modulus x upon x. Solve this. You will be required to use the definition of modulus. Okay. How we write the terms after we remove the modulus sign. Anyone calculated right hand limit?
So 1.
Yeah, correct. LHL?
So I only did RHL.
Okay, just try LHL also.
So 1 and -1.
Yeah, good. That's correct. So answer will be does not exist. See, first let us find RHL. So RHL means x tends to 0 plus. All of you listen very carefully. Okay, these are important questions. So first thing, how to write RHL? X tends to a plus. Now what changes we make from here? We write h tending to 0, and in place of x we write a plus h everywhere. What is a here? A is 0. This question is a, right here. So this is 0. So this becomes limit h tending to 0 mod h upon h. Now this is the deciding step here. I am going to write h and then I am going to write 1. How I am able to do this? Because what I said about h, it is a very small positive number. So though very small, but it is positive. And if it is positive, then what I told you about modulus, it always gives the positive answer. So if h itself is a very small positive number, that means mod h will be h only, right? Mod h will be h, and then what will happen? Numerator and denominator will become same and answer will come out to be 1. When we write LHL, that means towards left of 0. For that we show this with this negative sign. Then in place of x we write 0 a minus h. A is 0 here in this question. Okay, so this comes out to be limit h tending to 0 mod of minus h upon minus h. Now finally, again that same definition of modulus. Numerator we are going to write h. Why? What I said, modulus always gives a positive answer. Since h is positive, okay, h is always positive. In this chapter h will be a positive quantity. Since h is positive, so minus h will be negative. If minus h is negative and we are removing modulus sign, so how we will write? Remember, modulus x is minus x if x is negative, if you remember this thing. Since we have mod of minus h, so when you are removing modular sign, it will be multiplied by minus. Why? So that it gives a positive value h. Simple. Because of this, the answer of LHL is minus 1. What do you observe? LHL not equal to RHL once again. This implies limit does not exist. So many times you may get limit does not exist. But if LHL and RHL are coming equal, then they may be equal as well. Okay. Okay, try to find this next question. Solve this question. Okay. Fourth one. Let us find RHL first. This x tends to 2 plus. Write this x square minus 6x plus 8 upon x square minus 5x plus 6. Then replace x by a plus h. Okay. So it will be 2 plus h whole square minus 6 into 2 plus h plus 8. 2 plus h whole square minus 5 times 2 plus h plus 6. Now we solve this. So this is 4 plus h square plus 4h minus 12 minus 6h plus 8. And this is 4 plus h square plus 4h minus 10 minus 5h plus 6. Okay. So when you will simplify this part, see this 4 plus 8 is 12, so minus 12. This will be cancelled. So h square minus 2h will be remaining. In the denominator, 4 plus 6 is 10, so minus 10. This will be cancelled. H square minus h will be there. Now what you can do, you can take h common and cancel it. So it will be h into h minus 2. Denominator is h into h minus 1. Now this can be cancelled. Now what is remaining? So you should always look for the terms which can be cancelled first. Okay. Now this is remaining. Now nothing can be cancelled further. Okay. So if you put 0 here now, if you say that h is tending to 0, that means numerator is tending to minus 2 and denominator will be tending to minus 1, and that is why the whole answer will be tending to 2. This is your RHL. Okay. This is RHL. Okay. Try to cancel whatever you can. Try to write the function in the simplest form and then you put the value of h. So RHL is coming 2. Now similarly we have to find LHL. Limit x tends to 2 minus x square minus 6x plus 8 upon x square minus 5x plus 6. This is limit h tending to 0. This is 2 minus h whole square. 6 into 2 minus h plus 8 by 2 minus h whole square minus 5 into 2 minus h plus 6. Okay. Same way you proceed. 4 plus h square minus 4h minus 12 plus 6h plus 8. This is 4 plus h square minus 4h minus 10 plus 5h plus 6. So this gets cancelled. Similarly, this gets cancelled. It is h square plus 2h in the numerator and h square plus h in the denominator. Then we take h common and cancel it. Okay. After cancelling, it is in the simplest form now. So now you can put h as 0 because when it is tending to 0, numerator is tending to 2, denominator is tending to 1 and the whole value is tending to 2. So now you can see that in this case limit is going to exist, right? Because both of them are equal to 2. Okay. So what is the final answer? You can write limit x tends to 2 x square minus 6x plus 8 upon x square minus 5x plus 6 equals to, this is the final answer. Anyone have any doubt can ask. Okay, then there is another type of question which belongs to this thing only, LHL, RHL. Just the way of asking is a little bit different. Yeah, for example, if we take this question, find limit x tends to 1 fx. Okay, this is the question, and fx is given in the form of two branches, which is actually called piecewise defined function. Okay, so you can read fx as 1 plus x square when x is from 0 to 1, and you will read fx as 2 minus x if in the question x is greater than 1. Okay, so like this they define some function, they give some function like this. Okay, and on the basis of that you will be required to find the limit of the function at a particular x. So suppose I want to find RHL, which means x tends to 1 plus of fx. Okay, then can you tell me that which of the two branches you are going to select here in this particular limit RHL? Is it the upper branch or the lower branch?
Second one.
The second one. And the reason is simple. Reason is simple, that fx is 2 minus x when x is greater than 1. So in RHL, when you take x tends to 1 plus, okay, what is the meaning? 1 plus means greater than 1, right? Because the number is to the right of 1. That is why. Only this you have to understand, nothing new. Then what you will do? You will replace x by 1 plus h. You will replace x by 1 plus h. Now it is a simple question. This thing will come out to be 1 minus h. Okay. Now that same concept, when h is tending to 0, The
Sir, there is
limit.
some disturbance.
What disturbance? What about others? Am I audible or like there is some problem?
Sir, now you're audible.
Okay. So RHL is 1. Okay. Now LHL. LHL is limit x tends to 1 minus fx. Okay. Now since in this particular limit x is coming from the left side of 1, so it will be less than 1. That is why we are going to take the upper branch, right? Because fx is 1 plus x square whenever x is lying from or varying from 0 to 1. Okay. So here we are going to take 1 plus x square. Now in place of x we are going to put 1 minus h, right, and then square it. So it doesn't matter whether you open the square and then put h as 0 or you directly put h as 0, because answer is going to be 2, right? There's nothing to cancel, you can't simplify, it is already in the simplest form only. It is just like value putting kind of question. So when you calculated LHL at x tends to 1, it is coming out to be equal to 2. That means LHL is not equal to RHL. Okay, and this implies limit of fx at x tends to 1 does not exist. This is the mean. So solve one question based on this above concept. If fx equals 4x minus 5, where x is less than equal to 2, and x minus lambda if x is greater than 2, then find lambda if limit x tends to 2 fx exists. This is the question. Yes, anyone got the answer? It is given that limit is existing at x tends to 2. You have to use this fact, and on the basis of that you have to find lambda. You find RHL first.
So is it 5?
1,
So 5.
5. No, these are not the answers. Just check your calculation.
So -1.
Yeah, that is correct. Good. -1 will be the answer. See how. First you find, let's say, RHL. So since it is x tends to 2 plus, so obviously you will be taking the lower branch, which is x minus lambda. Okay. Then you write limit h tends to 0 and you replace x by a plus h. Now since it is a value putting question, it is already in the simplest form. Just put h as 0, you will get 2 minus lambda. This is the limit RHL. Now you find LHL. This is limit x tends to 2 minus fx. Now as you can see from the function that you will be using the upper branch, because you read fx as 4x minus 5 and x is less than or equal to 2. So from here we replace x by 2 minus h. As I'm saying again and again, generally these questions are value putting kind of questions. You can put h as 0 here, right? Directly. You will get 3. Now in the question it is given that limit exists. This is given that limit x tends to 2 fx exists. Is already given. That means LHL and RHL should be equal. So you equate these two and from here you will get the value of lambda. So this means 2 minus lambda is 3. Lambda comes out to a minus 1. So you can see these type of questions also in NCERT or whatever school textbook you are following. Now see, sometimes in the question they may be interested in finding only one-sided limit. So if that is the case, fine, we will just find that sided limit and we will solve it. For example, this is the question. Wait a minute. Suppose this is the question, okay. Limit x tends to 2 minus, and this is for greatest integer. Or the question can be limit x tends to 1 plus x square minus 1 upon x minus 1, okay. Sometimes they can ask the question like this. That is why I have given the heading one-sided limits. So if that is the case, you just find that limit and give the answer. What is the problem? Okay. So actually in this question, they want you to find only the left hand limit. It is already given 2 minus. So you just find that limit. So LHL is required. Limit h tending to 0 and in place of x you put a minus h, okay. And as you know, it is greatest integer, so any number less than 2 in the neighborhood of 2 will be 1. It will be 1.99 like that, okay. No need to find RHL and see whether the limit exists or not, because the question itself is find this one-sided limit, okay. Similarly, in the next question, you are required to find only RHL, just RHL. So you put h as tending to 0 and replace x by 1 plus h, right? Solve this. So I gave you this question so that you do not get confused in the exam, okay. They want you to find just one-sided limit, so that is good for you, okay. Lesser calculation. Then You can take h common from here. Okay, this gets cancelled. Value is going to be 2. Simple.
So we can't directly cancel it.
Directly put the value. You want to put the value 1 in this question here directly like this?
No, sir. We can write x square minus 1 as x minus 1 into
Yeah,
x
you will
plus.
cancel x minus 1, right? You can do that. You can factorize. Actually, I'm coming to that point. We will have even more faster methods, not just this LHL and RHL. Okay. Those methods we'll study in the next class, not today. Okay. Where you will be evaluating the limits by factorization, rationalization, and then there are some standard formula as well, but not in today's class. Today you have to focus on this LHL, RHL thing, only this thing. What about this question? Just try this third one. Limit x tends to 2 plus. I want answer from you guys. This is the question. Solve it. Limit x tends to 2 plus x minus 3 upon x square minus 4.
So minus 1 by 4.
Minus 1 by 4. No. Anyone else? Any other answer? See, I just told you only one thing, no? Just follow that. There is also one side limit. You are supposed to replace x by 2 plus h. Simplify this. What you will get in the numerator? H minus 1. What about denominator? 4 plus h square plus 4h minus 4. Okay. Cancel this. H minus 1 upon. Now you cannot actually cancel anything. Even if you take h common from numerator, no, sorry, denominator, it will be h plus 4 and that is not going to be cancelled. So then let us leave it like this only. Let us leave it like this only. Because now even if you take h common, nothing is happening. So then we are left with no option but to put the values. When you will put the values here, can you tell me what will be the answer? Yes, what will be the answer?
So infinite.
Infinite, and in infinite also you will write minus infinite. You know why? What is there in the numerator? Minus 1. Minus 1. What is there in the denominator? 0. Minus 1 upon 0. Because the infinities are also of two type, plus infinity, minus infinity. Okay. So you'll be required to give the answer not just infinity but with proper sign also. So here the answer is minus infinity. I hope this is clear. Solve fourth part.
So fourth one is infinity.
Fourth one, infinity. Yeah, because it is direct question. It is only RHL. You write h tending to 0 and in place of x you write 0 plus h. Okay. But you can't do anything beyond this. It will be 1 upon 3h. Now 1 upon 0, this will be infinity. Actually it is not 0. As you can see, it is tending to 0. I can show you something. You'll understand what is happening here. See, when I write 1 upon 0.1, try to understand. 1 upon 0.1 will be 10. 1 upon 0.01, 100. 1 upon 0.001, 1000. Are you getting it? What is happening? When you take this denominator close to 0, number is going on continuously increasing. Now, have you ever wondered, like if I write 1 point and then so many zeros, as many as you want, and then somewhere 1, what will be about this number? It will be a very big number. A very big number is like absurd in mathematics. What is this very big number? Something which cannot be defined. Okay. For that we are using this infinity. And if we take a very small number, like you go on putting this negative sign, now it is minus 10. Next time it is minus 100, which is a smaller, minus 100. Okay. Then if you write like this, minus, what is happening? How many zeros? You see yourself. Okay. Minus 1000. So now the number is getting continuously decreasing. So a time will come when a number will become very, very, very small. That will be like close to minus infinity. Okay. I hope you get it. This is the thing. So that is why we are writing plus infinity, minus infinity. Okay. Keep this in mind. This sign is also important. Now, what about your homework? I gave you some homework in the previous class. Introduction to three-dimensional. Anyone having any doubts in that chapter? In exercise 12.1, they have given this first question like this: a point is on x-axis. A point is on x-axis. What are its y and z coordinates? What are its y coordinates and z coordinates? What will be your answer? This is the first question. Yes, who will answer?
So y and z will be equal to 0.
Yeah, just wait a minute. Obviously, I told you the point is on x-axis. So in 3D, if you remember, this is straight from our notes. We take a point like this, x, 0, 0. Okay, if the point is on y-axis, coordinates are 0, y, 0. If point is on z axis, coordinates are 0, 0, z. The second question is a point is in xz plane. What is its y coordinate? What is its y coordinate? Now what will be the answer? Yes, anyone? Point is in xz plane. Y coordinate will be 0. You can take the coordinates as x, 0, z. If point is in yz plane, you can take the coordinates of point as 0, yz, 0, y, z. Okay, like this. Then see, the third question is there are some points. Okay, you have to tell the octet number in which points lie. Who will tell me answer of first part? 1, 2, 3. It lies in which octet?
So 1,
Yeah, correct. See what you will do in exam. What you are going to do in exam, you will write the first octet and also you write this thing as well. O, X, Y, Z. Okay, you write both. First octet, that is obvious. Okay, write this thing also. So whatever teacher wants to see, okay, you will get full marks. Then 4 minus 2, 3. What about this one? First you tell me the octet number and then we'll write it in terms of alphabets.
So 4.
Fourth one, because in first 4 z is positive, so x positive, y negative. X positive, y negative means fourth octet, and this can be written as O x y dash z, right? So like these they have given some point. It is so easy exercise. It will hardly take 2 to 3 minutes. Then the fourth question is fill in the blanks. Fill in the blanks. First part is the x-axis and y-axis taken together determine a plane known as xy plane. X and y axis they form xy plane. It is like this, right? This is x axis, this is y axis, so this is xy plane. Okay, similarly this is yz plane and this is xz plane. The two axes will determine the name of the plane. Simple. Then again, the second part, the coordinates of the points in xy plane are of the form. This we have already discussed. Coordinates of the point in the xy plane are of the form x comma y comma 0 because z coordinate will be 0, that is why. And the third part was coordinate planes divide the space into dash octants. So 8 octants. Such a easy chapter and very simple exercises. Basically, there are 3 exercises having very few questions in each, like 4 to 5. And then there is this miscellaneous exercise on chapter 12, where like there are only 6 questions. Okay, only 6 questions. So when you will have class on Monday, okay, you will have class on Monday, and it will hardly take 1 hour to solve all the exercises, including miscellaneous. So ask the doubts, okay, ask the doubts on Monday. Then we will continue with the chapter limits. So
Excuse me, sir.
yes,
Sir, could you please explain question 4 from 12.3?
12.3 question number 4. Wait a minute. Okay, using section formula, you want to see that the points are collinear. Yeah, this is a good question. See, exercise 12.3, question number 4. Question is using section formula. Using section formula, show that the points A 2 minus 3 4, B minus 1 2 1, and C 0 1 by 3, 2 are collinear. This is the question. So generally you might have proved 3 points collinear by area of triangle. We show that area of triangle is 0. Okay. And in 3D I told you one thing, that sum of distances between two pairs is equal to third pair, distance formula. But here they want us to use section formula. Got it? Section formula. What we are going to do, listen very carefully, it is a good question. Let B divides AC in so not like this. So they want us to prove that they are collinear. So what we'll do, we will say that let ABC are collinear. We are assuming it. Let ABC are collinear such that any one point, say B, divides AC in ratio m is to n. So if everything is like assume, what we are trying to check, how we will confirm that actually the points are collinear, just draw the diagram. 2 minus 3 4, it is 0 1 by 3 2. This is A point, this is C point, and B point is minus 1 2 1, and assume these points in some ratio m is to n. Okay, now find the ratio from each of the x, y and z coordinate. I am using section formula. Minus 1 is equal to 0 into m plus n into 2 upon m plus n. So we get minus n equals 2n. Okay, minus m is 3n, m by n is minus 3. That means ratio is minus 3 is to 1. That means actually B is there, B is outside, external division, but it is fine, leave it. Now use section formula for y coordinate. 2 is equal to this one. 2 is equal to m into 1 by 3 plus n into minus 3 upon m plus n. Again, 2m plus 2n is m by 3 minus 3n. So this is 5n is equal to m by 3 minus 2m. 5n is equal to minus 5m by 3 after taking LCM. This gets cancelled and m by n, this is 3n equals minus m, or m by n is minus 3. What do you observe? Same value, right? Now apply section formula for the third value, that is z coordinate. 1 equals m into 2 plus n into 4 upon m plus n. Cross multiply this, okay? Cross multiply. So m plus n is 2m plus 4n. This is minus 3n is equal to m. So what is m by n? M by n is minus 3. What do you observe? That every time you are getting the same ratio, okay? Every time you are getting the same ratio, and this is the concept. If from all the three coordinates, okay? If from all the three coordinates you are getting the same ratio, try to understand, okay? If from all the three coordinates you get the same ratio, you will say that our assumption that they are collinear was correct, and see this is the ratio. But like if applying section formula for x coordinate, y coordinate and z coordinate, you get different values of ratio. You get different values of ratio, then you will say that these points are not collinear, because see, try to understand, if the points are collinear, if they are on the same line, then section formula will be satisfied, and if that is the case, then whether you find a ratio from x or y or z coordinate, it should be same. So if it is not coming same, that means points are not on the same line, that is why different ratios are coming. Okay, so this is the concept we use. Hence our assumption, okay, hence our assumption that ABC are collinear is true. And what will be the next line? And we see that B divides AC externally in ratio 3:1. Okay, we have even checked this also. B divides AC externally in ratio 3:1. This is the way to write this answer. Is it clear?
Yes, sir.
Any other doubt? Those who have done the exercises, any other doubt? You have one more turn, that is on Monday, to ask your doubts from this chapter. Okay, I am saying again and again, it will hardly take 1 hour and you will be able to score good marks in your school exams. Okay, don't be so lazy. Solve these questions and ask if you have any doubt on Monday, and then we will complete this limits and derivatives chapter in the next week. Okay, limits and derivatives, this will be completed, and it may be possible one smaller chapter like a statistics may also be completed. So let us see. Okay, that's it for today. Thank you.
Thank you, sir.